This month's Building Forensics Mastermind series webinar, we're talking this month about sticking to your guns, about diagnostics being hard and fast proof that you either did a great job, that someone you know did a great job, or that you have identified opportunities for improvement. All of that is good, by the way, because remember, it's really important to know where you are in the vast scale of where the universe takes us. You want to know exactly where you are in it, how good exactly you are. So the information is never bad. Whenever you're using building diagnostics, it's always going to be a good thing. So over here on the left, you can see me with my beautiful wife, Grace. We are going to be building a high-performance tiny house, or rather a performance-proven tiny house. It could be high performance compared to some things, low performance compared to others. But it's going to be measured like crazy. We're going to go on tour next year. So before we get into any more discussion about what all that stuff is, in case you don't know who I am, Corbett Lunsford, I test buildings all day long. And so one of the things that I saw this past month was this. I was in LA, and this is the winner for this past month. We went to this little mystery room place, and if you haven't seen these places, it's like you get trapped into a room and you have to solve riddles to get your way out. It's pretty cool. But anyway, we walk into the place, and it's supposed to be this insane asylum, which is supposed to be dank and dirty, but the waiting room is supposed to be clean. And of course, there's a cup in the middle of the floor that's collecting the water that's dripping through the ceiling, which you can't see anything on. And I whipped out my infrared camera, which I always keep in my pocket, pointed it at the ceiling, couldn't see anything. I couldn't see a big wet spot. Turns out that the wet spot could not be seen because it was everywhere. It was the entire ceiling. So I popped up in their ceiling cavity because they happen to have a ladder, and I took a look around because in general, I don't like it when people don't know what they're doing and they've got this kind of a problem because this is technically an emergency. And what they're about to do is call a roofer or an HVAC professional, and they're going to say, just fix the problem. And they won't know for certain whether the problem got fixed or not. So I like to make sure that I can help if possible. So what happened is we've got an HVAC system inside of an attic, the floor of which is not insulated, the ceiling of which is not insulated, and there is roof vents between the roof cavity and outside. And the supply plenum there on the left, where the shiny insulated duct is going up to connect with the not shiny but still insulated supply plenum, that is our problem, is because air can get through that insulation and touch that metal, and that is the main problem here. The reason that that mylar shiny stuff is on that duct is because it blocks air from being able to get to that duct. So what we've got is this dripping wet metal that you can see on the right there, and it resulted in a floor that looked like this. The entire floor of the attic was all one standing puddle, and it happened to be pooling and dripping through the lowest point in it, which was the most damaged. So they will be replacing some portions of ceiling at this point, but the fix for this was super easy. Just re-insulate that box. It took almost no time to identify it. It would take almost no time and no materials to actually do the job. So that was fun. Now, as we go through this month's materials, remember that although I do talk fast, and as you have questions, by the way, feel free to type them into your questions pane, because that way you won't forget them, and I won't be able, I won't have to wait at the end to get some questions to answer. But even though I talk fast, there is a lot more stuff that you can do. You can watch videos, you can listen to my radio show called the Building Performance Podcast, you can read the book, you can work with the software that I developed so that I could work with it. You can get certified. I consult for people around the country, and the Mastery course, which I'm going to talk about at the end, which is Fall Fast Track, that happens this Saturday is when it starts. So I hope that you will check that out at the end of the webinar. So testing, adjusting, and balancing. We're going to be talking about the fact that there are two instruments on this screen. Now, the one on the left is an analog. You can see the gauge is moving. It's just based on the instrument sending an electrical signal to this little gauge that's going to move the needle. The one on the right is digital. Those two things are going to measure differently, and also these two instruments are made by different manufacturers. They've gone through different experiences in their lives. They will be measuring differently, and that is the subject of last month's most stressful situation, which was that the instrument on the left is owned by the HVAC installer on a huge building that I've been working on that you've seen some more stuff about. And my job is to verify that although everybody says, oh yeah, we deliver within 10%, plus or minus 10% of what is in the plans, actually it turns out that's, number one, difficult to do, and number two, it's not being chased after that hard. So my job is to keep everyone on this construction site honest. So I bring my own tool, and that tool on the right you've seen in a video where I use it to calculate a K factor, and if you don't know what that is, you can watch the video, of that register. That is a rental. I don't own that piece of equipment, I rent it from someone else. Now, the instrument on the left is used by the installer. Now, there are a couple things that I want to know about this instrument because, of course, the tool itself is going to be pretty good or very good or not very good at all at actually measuring reality. So first thing that I want to know is it analog or is it digital? Analog is going to have more of an error related to it. Number two is what is the plus or minus percent accuracy? And then also built into that will be a plus or minus CFM accuracy. So the instrument that I was using, the digital one, has a plus or minus 5% accuracy, plus or minus 5 CFM. So if we were measuring 100 CFM, let's just say for example, that would be 95 to 105 plus or minus 5. So it would be 90 to 110 would be the range that I could expect would be about reality for that instrument. It turns out that that's not what was happening with my instrument, and it's not what's happening with this one either, because the annual calibration that is recommended by the manufacturer has not been taken care of. You can see here in the middle of the screen where underneath the gauge there it says calibration date May 2008. So we have an issue here in that this instrument has not been calibrated or tested for accuracy in 7 years. Now the instrument that I'm using is also out of date. It's been calibrated in 2011. It's not my instrument, it's not my job to send it back, but I am kind of worried about the fact that it's not as calibrated as it should be. So what I did is set up this test. Very, very simple, and I'm actually going to be releasing a video on this at the end of the week on Friday. So I hope that you stay tuned for that on the YouTube channel. So essentially this is a flow hood hooked up to a duct tester. And what we do is we create a known airflow because that duct tester is built to move very specific amounts of air. In fact, what it's actually built for is to measure very specific quantities of air, but I can reverse it and I can just use it to create a known airflow. And then I'm going to see what the flow hood says. So this is how I came up with this result. Now, what you'll see is at the very low end, I did essentially 50, 75, 100, 150, 200, 300, and 400 CFM. That was the range of results that I was reading for this job. So I wanted to know how it performed throughout the entire curve of the range of flows. So when it was reading, I was actually creating a 50 CFM at the very top flow, what I was actually reading on the flow hood was 82 CFM. That's 167%. That's a 67% error on a very low flow. That means I don't use this flow hood to test exhaust fans or residential supplies in a normal residential system. Now, I happen to know that the residential supplies in this building, because it's a one-bedroom, there are 2 registers with a ton and a half air conditioners. That's 600 CFM. That's a 250 and a 350 CFM flow out of those residential registers. That's incredibly high. So I'm not worried about that in this building, but the exhaust fan flows for sure are not going to be useful with this tool because it's going to be wildly inaccurate. When we get up to 150 CFM, you can see that we're almost exactly in line. It's almost a 100% perfect number. And once we get above 150, when we're in the 200 to 300 range, we're getting down to like, there's a 13% error. So that is how I then interpreted the numbers that I was getting with my flow hood to give this installer company the benefit of the doubt. And I was giving them all of the possible allowance for hitting the 10% rule with including the 13% error of the tool that I'm using. Now, I'd rather not be able to do that because it would be best to just calibrate the thing. But sometimes you're just going to have to deal with what you've got. So in this case, this is one way to field check how accurate your testing tool is. And you should be doing this all the time because the test results are only as good as the operator and the equipment. And obviously, you guys are the operators that care because you're watching this webinar. But your equipment is another story, and you just need to make sure that you take care of that. Now, in this building, there's also this interesting system. I was on the roof doing my inspection, and I said, what is that? Never seen anything like this before. So essentially what they've got here is all the dryers in the building, 4 floors worth of dryers, about 3 dryers per floor, are hooked together essentially in a manifold so that all the dryers connect to the same venting system. What you can imagine that means, if I was to turn on a dryer on the top floor, it's going to essentially pull air out of the dryer and push air into the vent system, which means potentially, if nothing else is happening in the house, in the building, and there's no wind and there's no allowance for stack effect and all these things, I'm potentially going to be pushing my hot, moist air instead of out the roof, down and out the third floor dryers instead, and filling all those dryers with hot, moist air. That's less than ideal. So what they've done, very smartly, is to install this booster fan. The booster fan is supposed to be very smart. It will sense the static pressure in the vent system for all of the dryers. And it wants it to be at a certain static pressure, let's say negative 0.1 inches of water column, which is what it was on the top floor. So we measured this at just rest when there were no dryers running. We found out that it was, in fact, negative 0.1 inches of water column, which is about negative 25 pascals. It's about the same as a duct tightness test. On the first floor, it was about negative 2 pascals. It was very, very tiny. And then when you kick on a dryer, it senses that the static pressure has changed, and it sucks harder. So basically, if you had all of the dryers running, it would be sucking at its hardest point, and it would be exhausting all this. So what we want to know is, does it actually work? So we've got a couple of dryer vents that are open, and I actually drilled into one on the second floor to be able to do this, but we just hook up our manometer. We're measuring the pressure in the vent with reference to the air inside the building, and we test it without any dryers running, and then we test it with dryers running. And you want to test it with one dryer running, and then activate another dryer, and then activate another dryer, and make sure that the static pressure stays the same. So essentially, we tested the vent pressure on the fourth floor and on the first floor, and I could have done second and third if I really cared to. It would have been a gradation of between the first and the fourth, and find out that in fact it does work. It always maintains a negative pressure in the vent system so that the vents are sucking on the building all the time and never pushing air from the vent system into the building. That was awesome. So here is the other nightmare that I had last month, which was duct testing. We've got a number of apartments that are supposed to be passing Energy Star. And Energy Star is unique in Illinois right now because it's actually worse than the state code. State code requires 4 CFM per 100 square feet. Energy Star requires 8 CFM per 100 square feet of total duct leakage. Now, Energy Star says that you always defer to the more stringent code requirement, essentially, except for the fact that when we're in Chicago, because they don't know how to do their job with what they've been dealing with from the Chicago fire, they've had this incredibly complicated code that is the Chicago Building Code, and they've just decided not to enforce the state building code because it conflicts with some of the things in their code. So unfortunately, that means that they're completely useless to building performance professionals in general. And it also means that I can't enforce a 4 CFM because it's not actually enforced for this building, which is in Chicago. So we have the 1-10-100 rule. When we installed this duct system, when we planned it with a manual D, and then we installed it, it would have cost, let's say, $1 to actually do this thing right. Once we've got it all installed and we've got drywall in and we're testing the duct tightness of this, and by the way, you have to do that for Energy Star because we have to wait until the equipment is in place, and the equipment won't be in place until the drywall is up for some insane reason. That has to do with scheduling. Then it's going to cost us 10 times as much to fix this system as if we had just done it at the beginning. And if we wait until there's actually a problem down the road when this place is lived in, it's going to cost us 100 times as much to fix it as it would have at the very beginning. So, first thing we always want to know when we run a test is, what do the numbers mean? You can see that I'm running the test at 25 pascals. I've got my duct tester 200 hooked up, and I'm running 186.5 CFM through this fan, which is in mid configuration. I always take a picture like this so that you can see the flow ring and the configuration on the gauge. And we want to know what we should be reading so that when I've got this HVAC installer over my shoulder and he sees these numbers, I can immediately turn to him and say, this is what this means. Okay, so remember that this is going to be expensive no matter what. And I had a whole bunch of these fail in the last month, which was kind of a nightmare. So the test expectations are as follows. First of all, when you run a blower door test, you want to know what standard you're going to. Right now, we do all air tightness tests for residential in air changes per hour. That is a volume specific number. That is not good. The reason that's not good is that the smaller an apartment is, the more it will be punished for air leakage, because the ratio of surface area to volume is totally different than a giant mansion that's 4 stories tall. That will be actually rewarded for being so big. This is why this is a dumb way to measure air leakage. Luckily, in one of the projects that I was working on recently, they actually wanted it measured for the commercial standard, and the commercial standard is a lot smarter. The people who developed that standard knew what they were talking about. That is measured per square foot of surface area, which is also harder to calculate, but regardless, you have to do calculations. So you want to know what the ACH 50 that you're hitting is. In Illinois, it's 5. For the 2012 International Energy Conservation Code, it's 3. For the 2009, which everyone else in the country is going to have to be on by 2017, it's 7. So you take that number times the volume divided by 60, and that gives you the top number for CFM50 that you could possibly have and still pass. For the duct tightness test, you're going to do the same essential thing, except it's per floor area served. So we're going to take the floor area, divide by 100, multiply by the number that you're allowed. In our case, it's 4 for the state code. It would be 8 for the Energy Star, in which I'm demonstrating right now. So when you have failed something, if you're listening to this and you're not a diagnostics expert, you need to ask, please show me where the opportunities for improvement are, because I understand that this is failing, but I would like to be able to fix it, and you are the expert who can help me. And if you're a diagnostics person, make sure that you give them the evidence of their own eyes so that they believe what you're talking about. Because actually, in this building that I'm showing you right now, I left after having failed a bunch of tests in a row. And I stopped before I tested all of the things that were in my scope, because obviously it was a total waste of time. Got a call next week from a colleague of mine from another state who said, hey, I just wanted to let you know I got called in to this job that you are working on, and they asked for our second opinion. So they wanted us to test your work and see what was going on. And we got all the same numbers that you got, by the way. So we backed you up. I just wanted to let you know that that happened. So I thought, oh, that's really nice. And I knew that guy's name. And I took it into the job with me the next week. Didn't mention anything because I didn't want them to think that I was upset that they called in for a second opinion. I actually really liked that. So during the day, somebody happened to drop a hint that they had actually had somebody in to do some extra testing. And to be polite, I was like, oh, that's cool. He said, oh, yeah, he knows you. This guy trained with you. And I thought, oh, that's really nice. What's his name? Thinking, I know what this guy's name is because he already called me. And they said, a name that I actually was not expecting, which means that they actually had not one, but 2 different companies in there. The HVAC company and the builder both hired diagnostic companies to come in and check to make sure that I knew what I was talking about. That was really a thrill. So anyway, you want to give them this, because once they're on board and they're like, okay, I get that this diagnostic actually means something, that is the edge of a duct boot connection to a drywall lip. And that is not air sealed. So that is clearly a visual representation of something that is wrong. And if you were to take off all of the grills around this place, it would show you the same thing. So when you are a diagnostics expert, or when you are hiring a diagnostics expert, this is how this works. And I feel very strongly about this, and even more strongly this month because I had a great story that had to do with this. You always pay for diagnostics before the test results get shared. Period. You see the period at the end of that. Now, this is incredibly important because diagnostics-wise, for me, I'm just going to say, hey, I'm Corbett, I'm working for you today, I'm going to do a duct tightness test, let's just say. I can set up the duct testing equipment, take all my measurements, know what I should be reading when I do the test, and then I hold out my hand for a check. At this point, if the client hasn't worked with me before, and they didn't get the 5 reminders that I sent them, reminding them that I do take payment before I actually run the test, or they mean to take issue with it or whatever, then they say, oh, you know, I'm good for it. We don't play those kind of games. Now, here's the thing. There is no diagnostic for whether someone is going to pay you or not. Everyone will say that they will pay you. Every single person, 100%. That is not true. Not everyone is going to pay you. And I've had plenty of people say, holding the check in their hand, are you sure I failed? Because I got your payment right here. And I'm pretty sure that if I don't want to pay you, I don't have to, and you already did the work. So can you pass me today? How about that? And I've had enough people do that who insisted that they were honest beforehand. I never take chances with this, no matter how nice anybody is. So this has to be non-negotiable. And in fact, when you make it a non-negotiable rule, people will respect you. If it's something that you bend on sometimes, they don't respect you. So I had a job, this job that I'm talking about, with multiple apartments, and they were failing. And at some point I said, okay, I'm going to keep on testing, but you haven't paid me for this. So if you can give me a check right now or a credit card, I'll tell you what's going on. But otherwise, I'm just going to have to keep testing this stuff and not tell you anything of what I'm finding, whether you're passing or failing. And of course, if I tell you when you're passing, and then I don't tell you on others, you assume that you failed on those ones that I didn't talk about. So I don't tell whether they pass or fail. And they actually really respected that. And I got all of the subcontractors that I was working with, including the superintendent, the general, to be pressing on the developer to pay me. They were all like, you got to pay this guy right now. It was amazing. So they really got it, and they understood that it was a rule, that it was important. This is important for two things. Number one, it protects you, the client. If I get paid after I tell you how good you did, don't you think that I would be incentivized to tell you that you did better than you actually did? So that is one thing. You know for a fact when I test for you that I will always tell you the truth, because I have no incentive to tell you anything except the truth. I already have my money. I'm going to tell you exactly what's going on. And the second thing is, obviously, it protects the diagnostician. I've had enough jobs, and I've heard of enough jobs from my students that people have still not been paid for something that they failed on. And in fact, I've racked up thousands of dollars of extra diagnostics on a job where they had to get Energy Star, and that's in quotes, and then they just decided not to get Energy Star. So that can happen as well. And remember that professional services, and that's capitalized for a reason, that's like engineering services, structural engineering, things like that. It's called professional services, and that's the way it works, because that is your leverage. The numbers are the only leverage you've got. So I hope that you've enjoyed this. I'll start taking questions now, but remember that this Saturday, Fall Fast Track begins. Fall Fast Track is the Mastermind course for performing home performance contracting services in the free market. Everybody's talking at this point about BPI and HERS ratings and their code, or they're incentivized by rebates. I work entirely in the free market, and I don't need to worry about paperwork for rebate programs. I don't need to worry about trying to upsell people on, oh, you can get this much money back, or we can do this, and this is code stuff. You can leave all that behind if you can actually prove that you do better work than the competition, and that is what this is all about. So I hope that you check it out. It's at homeperformance.training, and I hope that you tune in next month. So